Okay, welcome to Math C. We're going to be looking at some of the things we've been working on today and this week. The first one is something that you've already gotten, so we'll just take a look at it again. I know some of you were gone, so we'll just keep plugging away at it. I'm going to show you the same way I did it on the board, and we'll just let this be equal to, and then I'll break it down to its little components. We know that 15 is made of 3 times 5, and we know that a squared is a times a, and we know that b is just b. So there we go. And then we have on the bottom 5 times a times b squared, which is b times b. Now we have something real easy we can do. 5 divided by 5 is 1. A divided by a is 1. B divided by b is 1. So let's just clean up what's left there. We have on top still a 3 and an a. On the bottom we only have b. I guess that line didn't need to be as long. So eventually you'll be able to go right to the equation and understand, okay, if I have a squared on the top and a on the bottom, I can just take away the 2 right there because I have 2 of them and I still have that a there that we can cross out. Just like here. Here we have 2 a's and then we cross out that one. So until you get used to it, you might want to just go ahead and draw everything out and see what happens. And then when you're used to it, you can go to the next part. Let's take a look at another one then. We have c squared times d plus c times d squared. I'll go ahead and make a nice big long version of this again till we get used to it. C times d plus c times d times d. Then on the bottom we have c plus d. Now I know a lot of you from earlier work with fractions have a tendency to just want to cross out right at the beginning, but we can't do that because there's a plus here. So the product of these and the product of these have to be taken into account. Let me just show you what I mean here. Okay. Let's look at what they both have in common. There's a c there and a c there. So both terms have a c and both terms have a d. So those can be rounded up and factored out and pulled over to here. So we have a CD there. Now we have to use a parenthesis. We got to ask ourselves, what's left? On the first part, there's a C that we did not pull out, so we'll put that here. There's still the plus there. And then we have a D. Okay. Now on the bottom, we didn't do anything. We still have C plus D. Now, to help your mind in the beginning connect these dots, I'm going to put a parenthesis there because what we're doing now is crossing out this and this because it's C plus D divided by C plus D, and all that's left is CD. Now, you may wonder, why does that work? Well, whatever C is and whatever D is, after you multiply them together, it's just a number. So let's just call the number 10. Let's just pretend that's what it was. Then whatever is left, it's 10 times whatever's inside. Whatever's inside, let's call it blob. And it's the blob on the bottom too. The same blob, because it's C plus D and C plus D. This divided by itself is 1. So everything that's left is just what's right there. And it would have been 10 times 1. So that's why we can do it. Now, remember that the factoring that we've done up here is the opposite of multiplication. So we're pulling out what we have in common and putting it here. Let's take another one. Now, this one's kind of fun because we have two polynomials divided by each other. And the first thing to do is try the little trick that I showed you before. Oh, that was the wrong pen. Here we go. Okay. This is the trick that I showed you guys, and I'll take it from the beginning so that you see what's going on. Okay. We're going to try and factor the top part first. And the way you do that is you look at this number first, 9, and you ask yourself, what makes 9? 3 times 3 and 9 times 1. Because we're only interested in the whole numbers on this. Before we put any numbers down, let's go ahead and put the X there. Now we say, okay, 9 is made of 3 times 3. So if it's going to work with whole numbers, then you just put them down. In this case, it happened to be the same number. Then you look at the -6. Say, okay, interesting. The way it works is the 9 has to be the result of a number times another number. The -6 has to be a result of the A combined with the B. We're adding them together, putting them together. Now, that doesn't mean A is negative. It doesn't mean it's positive. It's just whatever number it is, you put it together with B. So let's look at it one more time. 3 times 3, when they're both positive, turns into 9. -3 times -3 would also turn into 9. But we need to put those two numbers together and get -6. So they both have to be negative. Now let's play with the ones down on the bottom. Let's go ahead and put our X there first. Now, what makes 39? And you can also ask yourself, when we add those same numbers, what makes +10? Well, for 39, there's a few combinations that we could try. And let's just remember, we have 2, 3, 5, 7, 11, 13, etc. Think of the prime numbers. There's an infinite number of them, but in this course, these are the ones that are going to come up most often. And when you're factoring polynomials or second-degree equations, it's probably 90% of the time you're going to get these kind of prime numbers involved, either as a component or as the prime number itself. Now, 39. Well, let's see. What can we do? Two numbers multiplied together. What about 3 and 13? Yeah, that would do it. Now, we don't know if they're both positive or negative or a combination of that, but we see that here it's negative. That means that one of these has to be negative. You can't multiply two negative numbers together and get a positive number. And you can't multiply two positives together and get a negative. So let's put in 13 here and 3 there, and then let's just see what happens. Okay, we know they have to be different. So what happens if this is negative, the 13? Well, if we did that and then added it to a +3, we'd get -10. So it has to be the opposite. This part has to be negative, and that has to be positive. So the -3 times the +13 will give us the -39, and the +13 together with the -3 gives us the +10. Okay, now what happens? Just like before, this x minus 3, just say, okay, it's a blob, and here we got one here. They divide each other out, and all that's left is x minus 3 on top and x plus 13.